This study proposes a new learning method that employs multiple embodied self-avatars during learning in virtual reality. We experimented with a sign language memory task and showed that the proposed method could prevent forgetting and enhance memory retention rather than constantly using a single self-avatar. The proposed method is based on the multiple context effect. It suggests that repeatedly learning in diverse situations can prevent forgetting and enhance memory retention. Then, we focus on diversifying self-avatars while learning in VR. Self-avatar is a body representation of users in a virtual environment, and previous studies suggest that it plays a critical role in memory formation within VR. We conducted a between-participant study using a sign language memory task. Participants learned 20 sign language actions in VR 6 times and completed a final test in the real world after 1 week. We compared the constant avatar condition, in which the participants used the same self-avatar throughout the learning, with the varied avatar condition, in which they used a different self-avatar in each of the 6 trials. This is a first-person perspective view of the experimental system. During an initial study trial, a word was presented in black letters on a white background in front of the participant, and the corresponding sign language action was presented twice through the female avatar on the left. A virtual mirror was placed in front of them so that the participants could see their movements. In the same manner, the participants successively studied 20 sign languages. Subsequently, to proceed to the next trial, we asked the participants to remove the head-mounted display and put it on again. The participants performed a retrieval practice trial. In this trial, they had to answer the corresponding sign language action to the presented word in 5 seconds, and it was followed by feedback from the neighboring avatar. In this way, they answered all 20 signs. The retrieval practice trial was repeated 5 times in total. Under the constant avatar condition, the same self-avatar was used throughout the 6 VR trials. In contrast, a different self-avatar was used in each trial under the varied avatar condition. The self-avatars included medical doctor avatars in white coats, businessperson avatars in black suits, military avatars in green camouflage uniforms, paramedic avatars in blue life-saving suits, firefighter avatars in yellow protective gear, and avatars in swimsuits. The participants used avatars of the same gender. The graph shows the proportion of correct responses in the 5 retrieval practice trials and the final test that was conducted in the real world after 1 week. The results showed that the varied avatar condition initially performed worse than the constant avatar condition. However, the gap disappeared as the learning process progressed. Moreover, in the final test, the varied avatar condition recalled significantly better than the constant avatar condition. Additionally, following the previous studies, we calculated the amount of forgetting from the first day to the second day. The results showed that the varied avatar condition forgot significantly less than the constant avatar condition, with a large effect size. In summary, we demonstrated the effectiveness of the proposed method on sign language learning. This study presents an innovative design approach for the use of self-avatars in VR-based education.